our meeting here, and then I'm going to go through the next set of notes here. So this is the notes. So if you've got them on Cami, on your Chromebook, or if you have them on paper, I just want to review really quick what we talked about yesterday. So yesterday we talked about how you can take an equation, and if one of the equations says y equals or x equals, for example, this first equation had y equals, you can substitute the expression for y equals into the other equation. So we took the 3x minus 1, substituted it into the other equation where the y is. Okay, if you have to, on number 2, you can solve an equation for x or y. And on the third one, we didn't have to do that. We already had the y equals right here. So we have that y equals, so we were able to substitute that into the other equation for y. And that is called substitution. However, there is a third and final way to solve a system, okay? And that third and final way to solve a system is called elimination, okay? And the way elimination works is, well, let's take this system right here. So I have x plus 2y equals 5, and I have negative x plus 3y equals 10, okay? Now, if I take my first equation, x plus 2y equals 5, okay? Rules of equations. Am I allowed, when I'm solving an equation or just manipulating an equation, is it allowed for me to add the same number to both sides of an equation? Is that something that we've been allowed to do before? So if I add 10 to both sides of the equation, is that a legal move in equation solving? In other words, will it still be balanced? Yeah. As long as you add the same value to both sides, it is still a balanced equation. So yes, you can add 10 to both sides of the equation. So what if on the right I added 10 and on the left I added 4 plus 6? Is that still me adding 10 to both sides? Yeah, it's just two different ways to represent 10. It's still adding 10. So as long as I'm adding that same value, it doesn't matter what the value looks like. What matters is that it has the same value. Now, I look over here and I say, oh, wait a minute. There's 10. The other side of the equation says, you know what? 10 is the same thing as negative x plus 3y. So what that means is on one side of the equation, I can add 10. On the other side of the equation, I can add negative x plus 3y. So on this side, I can add negative x plus 3y. On the other side, I can add 10. The reason I can do that is because right here, this tells me they are the same thing. Negative x plus 3y is the same thing as 10. So it is perfectly okay to add negative x plus 3y on one side, 10 on the other. Now, we call this process elimination, because what we're going to do now is we're actually on step 3, and I'll go back to the other steps in a second. But if you look at step 3 at the top there, it says to add the two equations together so that you eliminate a variable. So I'm going to add these two equations together. So x plus negative x. If you add x plus negative x, and there it is, what do we get? So x plus negative x. We're basically just adding these two equations together. 0. Boom. Eliminated. X's are gone. Now let's add 2y plus 3y, 5y equals, and then on this side, we add the 5 and the 10. 15. Let that catch up. And did I get an equation that's now easy to solve? I don't know why this is taking so long to catch up. Please don't die on me and disconnect. There it is. Whew. Okay, so 5y equals 15. Can we solve that? Yeah, we know how to solve that. There's one variable left. What we don't know how to do is solve when there's two variables. So that's why we eliminated one. We got rid of the x altogether. So now we have 5y equals 5, or 15, excuse me. If we divide by 5, we know that y is equal to 3. So we now have an answer for y, okay? So if you take a look at what we did, we basically did these first few steps. Choose a variable that you want to eliminate. Well, I didn't necessarily choose. It was just the easy variable to eliminate was x. Step 2, we don't have to do that most of the time. So we didn't do step 2, but we did do step 3. I added the two equations together and eliminated a variable. Step 4, I solved for the remaining variable. I got y equals 3. Now I'm on step 5. I'm going to substitute that into one of the original equations. So I go to the original equations there. I pick one. Doesn't matter which one I pick. There's two equations there. So let's just say, hey, I'm going to pick this first one. And I'm going to substitute in a y equals 3. Now, when you guys are doing this, do you think this is the kind of problem you can completely do in your head? So if you're like on Delta Math and you're trying to solve problems on Delta Math, are you going to just sit there on the computer and do this whole thing in your head? No, you are not. Some of the stuff that we did in the first couple of chapters, you could. You could do maybe inputs and outputs in your head. You could see the domain and range on a graph, in your head. I mean, you could literally just see it on the graph. What we did in chapter 2 with the linear equations, you could look at a graph and figure out the slope. You might have been able to look at the table and figure out the change in x and the change in y without having to write too much down. You will have to write stuff down when you're doing systems, okay? Nobody is going to be able to do this completely in their head. I can't even do this completely in my head. But I do know that I have x plus 2y, and y is now equal to 3. So I'm going to put that in right there. And x plus 2 times 3 is equal to 5, or x plus 6 is equal to 5. Subtract 6, and now I know that x is equal to negative 1, not 1. So x is equal to negative 1. So I've got a y, I've got an x. That means I do have a solution. Remember that a solution is a point of intersection. Okay? And the point of intersection needs to be written as x comma y. Okay? Now, the way that these two equations were set up, it was way easier to do this process called elimination, because when I looked at this, I could see, hey, if I add, I'm going to eliminate my x's. I saw those two equations and I said, look, the x's will eliminate if I add the two equations together. Okay? Now, I do want to do a separate example that's not in the notes here. So I'm going to write a separate example here on the side. Let's make this 6. Okay, so here's another example. Okay. Now, if I add these two equations together, so meaning that if I add 6 to the 8, and then I add the x plus the 2y to the x plus y, notice that nothing will eliminate. So if I add, I would get 2x. Don't write this down because I'm going to erase it. I would get 3y, and then I would get 14. I didn't eliminate anything. This only works if you can eliminate a variable. So let's look at the x's. Adding doesn't eliminate these x's right here. But what could I do to eliminate the x's? So since adding gives me 2x, how could I make that 0? So adding doesn't work. What do you think is going to work? Subtraction, okay? So you can think of it as, oops, I just lost my tip of my stylus. That is funny. So you can think of it as, well, adding doesn't work. Maybe I can subtract. And in this case, yes, it will work. You can also think of it as, well, what does subtraction really mean? Subtraction means multiplying that entire second equation by -1. So I'm going to really subtract, or you can say I'm just going to multiply by -1. So my first equation, I keep the same. My second equation is going to become -x minus 2y equals -6. So subtracting means adding the opposite. So that means just changing the sign of everything, multiplying by a -1. And now we can eliminate. See, x plus -x, excuse me, eliminates. Y plus -2y gives me -1y. 8 take away 6 is 2. And if -y is equal to 2, I know that positive y equals -2. And now we can go back to either of the original equations. I like this one, the first one. That's super easy. X plus y is equal to 8. So for x plus y equals 8, I'm going to write x plus my y is -2 equals 8. And then I'm going to add 2 to both sides, and I can figure out that x is equal to 10. So my solution is 10, comma, -2. That's the point where those two lines would intersect. You can always check your answer. Take this point, plug it in here for x and y. See if you get 8. It's easy to check like on a calculator. Let's see, 10 plus -2, yeah, that's 8. Check it in here and see if you get 6. If I take x, which is 10, plus 2 times -2, which is -4, I do get 6. You can check it kind of mentally in your head or on a calculator, but that's how you will know whether it is right. You will know that 10, -2 is correct because of the two equations we started with. X plus y, if you add them together, you get 8. If you add the x plus 2 times the y, you do get 6. It works. Over here, when my solution was -1, 3, plug them in here. X plus 2y, you should get 5. -x plus 3y, you should get 10. And it's an easy thing to plug it in and check. Okay? Now, I know there's other examples down here on the page, but I don't want to do those yet because those do require multiplying your equations by something first. And we will continue that tomorrow. So I just want us to keep the basic elimination problem here, which is it's going to be set up where you can just add the two equations together like the first one was. You saw that the x and the -x eliminated. It's taking so long to be where I am here. Anyway, first problem, we just added. We didn't have to do anything. The second example I gave you, adding didn't work, but subtracting did. Okay, so when you're doing your Delta math tonight, it's going to be one or the other. You're either going to be able to add the equations and eliminate something. If you don't eliminate something, then it didn't work. That's the whole point. That's the reason we call this, screen broadcasting has stopped. Well, hopefully I've got enough of the notes here. I'm going to pause. Well, it doesn't really matter if I pause it or not. It's still sitting up there. So So what I want you guys to do is I want you guys to go to Delta Math so that you can start working on these. And same with, online people. I'm done with my notes here, so I totally lost it here. But I want you to get onto Delta Math, take out scratch paper and a pencil, because you cannot do this without paper and a pencil. You will not be able to do all of this in your head. Okay, so please have out paper and a pencil when you do it. It's going to ask you to do what we just did, and then you're going to type in your solution, which is a point. Yeah. It's not up yet? Okay, so hold on. I'm going to make sure that it's up. I'm going to stop the recording here because I don't think we need to record the rest of